funky font today? 3 by 3 So that's probably where your joy for today is going to end. Oh, yay! Okay. So 3 by 3 systems stand for 3 equations with 3 unknowns. Okay? So one thing to do is ask if an ordered triple, because now I've got 3 variables, so now it's an ordered triple. And that is usually in the form X, Y, and Z, or A, B, and C. Notice the alphabetizedness of the letters. Okay? That's usually how it goes, unless otherwise specified. Okay? So how do you think we would go about answering the question, is that ordered triple a solution to the system? Exactly. Plug those numbers in to each. Can I just do it into 1? No. Can I just do it into 2? No. I got to do it in all of my equations. Okay. Go for it. So 2 times 7 plus 5 times 1 plus 3 times negative 3 has to equal 10. 2 times 7 is 14. 5 times 1 is 5. 3 times negative 3 is negative 9. 14 plus 5 is 19. 19 minus 9 is 10. 10 is equal to 10. Then I check in the next equation. What if that one didn't work? Then it doesn't work. Yeah. If it doesn't work, it doesn't work. You're done. Okay? If it works, you keep going. So that's going to be 3 times 7 plus, minus 1 plus 4 times negative 3, and that's got to equal 8. 3 times 7 is 21, minus 1 is 20, minus 12 is 8. 8 is equal to 8. Then lastly, we've got to go 5 times 7 minus 2 times 1 plus 7 times negative 3, and that's got to be 12. So that is 35 minus 2 minus 21, and that has to be 12. 35 minus 2 is 33, minus 21 is 12. So it checks out in all 3. So yes, it is a solution. Questions on that? Now, that's all great, grand, and good if I give you the ordered triple as an answer. But that's not always going to happen. So you're going to have to sometimes find the ordered triple. And we do that using one of 2 methods. Either you can use elimination or you can use substitution. Okay? So here are the steps for elimination. Okay? before you even start, I would order or organize, I think is a much better word, as into equation number 1, equation number 2, and equation number 3. Just gives you a little more organization. So, my first step is going to be, I need to pick a variable that I want to eliminate. My choices are x, y, or z. X, we want to eliminate x. Okay? Everybody agree with that? Doesn't matter. If Nick wants to choose x, Nick can choose x, right? Rubes, if you wanted to choose y, that's fine too. Okay? We're all going to end up in the same location. It's just a matter of how we get there. Okay? We're all going to end up in Mosinee. Okay? Some of us might just jump on the highway. Some of us might go out to Marathon. Okay? Some of us might go over to Wittenberg and come back around that way. Some people might not take disaster though. Yep. Yep. Exactly. Okay? So we chose x. Okay? Then, step number 2 says, I am going to have to eliminate that variable twice. Okay? So, my first one, I am just going to add equation number 1 to equation number 3. Because that is going to give me negative 2x plus 4y plus 5z equals 5, and 2x plus 5y minus z equals negative 12, and when I add them, my x's go away. So that gives me 9y plus 4z equals negative 7. Good? Now the downfall is now I can't use equations 1 and 3 again. I got to pick something else. What do you want to pick? Either got to pick equations 1 and 2 or 2 and 3. What'd you say, Ken? 1 and 2? Good choice. Okay? But I'm not going to I can't just straight up add them, right? I got to first manipulate them a little bit. So I'm going to go 5, oops, it's still in that color, wrong color. I'm going to go 5 times equation number 1, and I'm going to add that to 2 times equation number, oops, I almost put equation number 3. 2 times equation number 2. Coloring. OCD is a real thing. Five times equation number 1 is going to be negative 10x plus 20y plus 25z equals 25. 2 times equation number 2 is going to be positive 10x plus 4y minus 6z is going to equal negative 2. When I add those two together, my x's go away. I get 24y plus 19z equals 23. Yes? Huh? Step number 3 now tells me that I need to use substitution and elimination. Wake up. Wake up or walk. One of the two. I need to use substitution or elimination on those two new equations to solve them for y and solve them for z. Okay? Substitution. Substitution tells me that I've got to solve one of those equations for one of those variables. Not the easiest, right? Right? I either got to divide 4 by 9 and 7 by 9, or divide 9 by 4 and 7 by 4, or I got to divide by 24 or 19. Not the easiest. So let's go with elimination. If I call this equation 4 and equation 5, and I can multiply 8 times equation number 4 and add that to negative 3 times equation number 5, then I've got 72 in front of my y. Okay? So 8 times the green one is going to be 72y plus 32z equals negative 56. Negative 3 times the red one is going to be negative 72y minus 57z equals negative 69. Add those two together. That gives me negative 25z equals negative 125. My y's have been eliminated. So z here is 5. What? We're only a third of the way done. Yeah, because we only got one variable. We got to get 3. Yeah. So then now we got to go 9 times y plus 4 times 5 has to equal negative 7. So 9y plus 20 equals negative 7. So 9y equals negative 27. So y equals negative 3. Now we're 2/3 of the way there.
Well, really aren't we farther than that?
No.
We have 2/3 of the answers, but a lot of the work
Which
is
is
already done.
2/3 of the way there.
But a lot of the work is already done.
Okay? So then my last step says that I'm going to plug those two values which I just found, I'm going to plug those back into one of my original equations to get the third one. I'm going to go with equation number 3. It does not. Because it should work, all three of them should work in all. Okay? So 2x plus 5 times y, y is -3, minus z, z is 5, has to equal -12. So that's 2x minus 15 minus 5 equals -12. Add 20 to both sides, because -15 minus 5 is 20. That gives me x then is 4. Now we can write our answer as an ordered triple, 4, -3, 5. But before we circle it and move on to the next one, we just spent a good 20 minutes working on one problem. Right? Almost. Counter's only at 7. Okay? But we spent a good 15 minutes, let's say, working on one problem. Do you want to know after working on a problem for 15 minutes if you're right or not? No? Okay? I do, because I'd be really frustrated if I did something wrong. Okay? So we've got to go back up to our original 3 equations, and we've got to try our answer in each one. So 4 times -2 is -8, plus 4 times -3 is -20, plus 5 times 5 is -20 plus 25, which is 5. So that one checks out. 4 times 5 is 20. 2 times -3 is -6. 20 plus -6 is 14. 3 times 5 is 15. 14 minus 15 is -1. That one checks out. 2 times 4 is 8. 5 times -3 is -15. 8 minus 15 is -7. Minus 5 is -12. So it checks out there in all 3. Therefore, I have now earned the right to call it my answer. Okay? That is the elimination process. Now we've got a process to go along with substitution. Again, before I start, I would order my column equations 1, 2, and 3. Substitution. What do you think our first step is going to be? For substitution. Now, pick an equation and a variable and solve for it. Okay? There are three equal and very smart choices, but they are all different. What are they? Solve equation number 1 for y, 2 for z, 3 for x. Okay? I've only got to pick one of those three, but those three are the smartest ones. Okay? Which one do you want to go with? First one for y? Okay? Alright, so we're going to solve the first equation. For y. So that's going to give me y equals 10 minus 3x plus 2z. Agree? Step number 2 says we're going to substitute that into the other two equations for y. So if I plug it into equation number 2, that's going to look like 6x minus 2 times 10 minus 3x plus 2z plus z equals negative 2. Distribute the negative 2. That gives me 12x minus 3z equals 18. Now I've got to put that into 3. X plus 4 times 10 minus 3x plus 2z plus 3z equals 7. X plus 40 minus 12x plus 8z plus 3z equals 7. negative 11x plus 11z equals negative 33. Yes? Yeah. Step number 3. You're going to use elimination or substitution on those two. What are you thinking? What if I solve the red one for z? That's going to be 11z equals 11x minus 3. So z is going to equal 33, I should say. Z is going to equal x minus 3. Yes? So now I can put that into 12x minus 3 times x minus 3, and that's got to equal 18. And I get x equals 1. If I put 1 back into my red equation, I get z equals negative 2. Now what do you think we got to do? Plug them back into an original equation, right? But let's be smart. Let's work smarter, not harder. Which of my original equations, if I'm got to solve for, what do we got to solve for now? Y? Which one should I plug them into? 1, because y is by itself. Yeah. Okay. So now we've got to plug that in for y. So 3 times x was 1, plus y minus 2 times z. Z was negative 2. And that's got to equal 10. So that's 3 plus y plus 4 equals 10. So y has got to be 3. What should we do now? We should check it. Okay? So let's go back up here. 3 times 1 is 3. Plus 3 is 6. 2 times negative 2 is negative 4. 6 minus negative 4 is 10. 10 checks out. 6 times 1 is 6. 2 times 3 is 6. 6 minus 6 is 0. Plus negative 2 is negative 2. It checks out. 1 is 1. 4 times 3 is 12. 1 plus 12 is 13. 3 times negative 2 is negative 6. 13 plus negative 6 is 7. Checks out in all three. I now can say that is my answer. Okay? Try it. So where should we start? No. Where should we start? No. How are we going to solve this? Guess and check? Or are we going to make some equations? What do we need for if we're going to make equations? We need variables. So we should first probably define some variables. Now what can we do next?
Then we can create the equation.
Now let's make some equations. Give me a first equation. X plus y plus z equals 6. That translates into the sum of three numbers is 6. Okay, give me the next equation. Could I write z equals x plus y? Okay. That tells me the third number is the sum of the first and the second number.
X plus 1 equals z.
The first number is one more than the third number, no. So it have to be x minus 1 equals z, or z plus 1 equals x. Okay? Do you want to do elimination or substitution? Substitution. I'm going to take the middle one, and I am going to plug it into the top equation. That's going to give me x plus y plus x plus y equals 6. Or 2x plus 2y equals 6. Yes? Then I'm going to take the middle equation and I'm going to plug it into the third equation. And that's going to give me x plus y plus 1 equals x. Or y equals negative 1. Right? if y is equal to -1, then 2x plus 2 times -1, put it the wrong way, has to equal 6. So 2x minus 2 equals 6. So 2x equals 8. So x equals 4. If x is equal to 4 and y is equal to -1, then z has to be 3. So my first number is 4. My second number is -1. And my third number is 3. The sum of three numbers is 6. 4 plus -1 is 3, plus 3 is 6. Works out. The third number is the sum of the first and second numbers. 4 plus -1 is 3. 3 is equal to 3. The first number is 1 more than the third number. 3 plus 1 is 4. 4 is equal to 4. The order of the numbers matters. Okay? So the order here of the numbers matters. Because if they're in a different order, it's a whole different ball. Okay? Good news, bad news? Bad news? You have 2 quizzes tomorrow. What?
Good news, this is due on Monday.
Okay.